2.3, complete the square method. So by now, some of you will wonder, how come there's so many methods? We have learned factorization, we have learned graphical. Why do we still need to learn complete the square to learn to solve a quadratic equation? So when you learn factorization, you do notice that some of these expressions cannot be factorized. They cannot fit nicely into the method that you learn, the table that you learn, whichever table your teacher has taught you. And it's also super time consuming to plot a graph. You have to fill in a table, you have to plot the points, you have to make sure the scale is correct, you have to sketch a smooth curve. There are so many steps involved that it's very easy to lose mark at any of these steps. Plus, it will not be highly accurate and exact, especially when it's plotted by hand. I can safely say that there's no two graphs plotted by students that are exactly the same. So sometimes you also doubt yourself when you want to read off your graph and, for the answer, you just like, can I trust my own graph? So this is why you want to learn complete the square method. Let's start with this example here. If I give you this and I ask you to factorize, you have learned this method or this method, depending on what your teacher has taught you. You know that these two terms will not fit into this table. And you have also learned the formula a square minus b square. You know that, okay, two terms, I can use a square minus b square to factorize a plus b, a minus b. There, I have my factorized form. But this is a plus. So there's no way I can use any of this method that we have learned before to factorize. So I'm going to tell you this method called complete the square method. If I compare this, I see that I have my x squared. This is my 6x. So this is the expanded form. Now I want to reverse it to the factorized form. Last year we have done so many practices of expanding this, okay, from this step, expand to all this step, open up the bracket. But now what I need you to do is to be able to see that we need to now reverse. Given this expression, you need to reverse into this, do some reverse engineering, okay, to get back the bracket. So if this is my 2ax, because if I want to factorize this back, right, I know that I definitely have my x, because x squared, that's how I get my x squared here. My question now is, what is this a? What is this a? What will my a be? So wait, the answer lies here. This is the 6x given to you, and once it's expanded, you see that this xx is actually 2ax. So what is this a that I want? So if 2ax is equal to 6x, my a is equal to 3. So I know that if I get my x plus 3 square, I expand this, I can get a square plus 2ab, which is 6x. See, I'm almost there already. Not the end, but I'm almost there. I have gotten this x squared plus 6x, x squared plus 6x. But when you fully expand this, there's always this term a squared, which is your 9 here. But the original expression that I asked you to factorize didn't have the 9. So technically, these two are not equal at this moment. So what should I do? If I expand this thing, I have this extra 9. I don't want this 9. Very simply, you just have to minus 9 at the back. Because once I expand this is what I get. But with this minus 9 behind, I put a minus 9, I introduce this minus 9. I do not have any more minus 9. I can safely say that this expression minus 9 is equals to x squared plus 6x. So there you have it. If I give you x squared plus 6x, I get this. This is what I call complete the square form. You have finished completing the square. So some of you will be like, I sort of get it, but I'm not too sure. Okay, I roughly know where this 3 comes from. I roughly know where this minus 9 comes from, but I'm not quite sure. Don't worry, a few more examples coming up. So express this in this form. Okay, this is a completed the square form. And this, if I were to try to factorize using the table given, this cross method, you will know that no matter how I factorize, okay, split up this negative 5, there's no way I can get a number big enough to make up to this negative 12. And you're not supposed to rely on a calculator because the question specifically say, I want this form. So this is asking you to do complete the square method. In this, let's think backwards. Remember just now the equation that I wrote in the previous slide? I have x squared minus 2ax plus a squared is equals to x minus a squared. This is what I eventually want to achieve, something that looks like this, right? Something that looks like this. But now I am given this. This is what you're given, the expanded form. So we usually will focus on this first. We'll ignore this last term. Let's focus on this. I want to have x. Definitely I'm going to get this x, okay, in this bracket square, because x squared, that's how I get my x squared. My question now is, if this is negative 2ax, what is my a? So this is always double, right? 2 times this number times x, that's how I get this. So this number, very simply, you just have to half it. So my a is just half of this number, which is 6. Okay, some reverse thinking, take some time to process this. I'll bring down this minus 5. So at this moment, we are not done yet, but at this moment, let's look at this. X minus 6 squared. If I ask you to expand, you are all experts, so let's expand this. X squared minus 2ab, which I get my negative 12. See, I get my negative 12x. Okay, because I just need to double this. But what is the one more term at the back? It will be plus 36. Right, your a squared, which is your 6 squared. So I have this plus 36. And that's not what I want, because this is not supposed to be there. So remember what we done in the previous slide? We just have to minus away this 36. That's not what we want. After I expand this thing expanded is x squared minus 12x plus 36. But I don't want this 36, so I just have to minus it at the back. There's no more 36 anymore. So this whole thing, what is left is just x squared minus 12 minus 5. Nothing has changed except for the way it looks. So we just have to simplify it now. Minus 5 minus 36, I have minus 41. This is completed the square form from here to here. One more example. So you see that, okay, this is x and there's a square here, this x, okay, because x squared, that's how you get my x squared. This thing, you can just bring it down. It's not going to bother you because we always focus on this first two terms first. So this first two terms, x squared, that's how I get my x squared. 3x. In order to get my 3x, what could have been in this bracket beforehand? The sign will remain the same. Plus will remain as plus. Like this one, minus will be minus remains as minus. Okay, so plus remain plus. 3x. How did I get my 3x? It will be 3 over 2. Why? Let's do this expansion now. This whole thing, if I were to expand, I have x squared plus 2ab, which gives me 3x. See, I get x squared plus 3x. Okay, then there's always this extra term at the back, which is your 3 over 2 square, your a square. Okay, there's always this square number at the back, right? But this is the extra term that you don't want. Once you put it in this bracket, you are introducing this extra term here that you don't want. So please remember to always minus it at the back. This is what you don't want. Okay, so we have this bracket. This is the factorized portion. And then this, you now have to you can use your calculator to just calculate what is 1 minus 3 over 2 square. Which is negative 5 over 4. Okay, 1 minus 3 over 2 square is negative 5 over 4. So this is the completed the square form. We can now move on to the solving the equation part. Okay, they want you to solve by completing a square. The question specifically state this, so don't try any other method. Whatever answer you give me, even if it's correct, okay, as long as the method is wrong, you're not going to get your mark. Solve the equation by completing the square. So usually what I will do is I will move the constant term to the other side, because usually we don't need this constant term. We always focus on the first two terms here, these two. I want to put them in the bracket. X squared will become x because this x squared, that's how I get my x squared. Okay, I've been repeating this part. How did I get my 2x plus 2x in the first place? Because it was halved. Before that, it should have been halved. Okay, I shouldn't put this equal sign here. Always remember, there shouldn't be two equal signs in one row. Okay, but this is not the end, this is not the end. If I expand this thing, I get my x squared, I get my 2ab, which is 2x. See, I get this, but there is always this a squared at the back. 1 square, a squared plus 2ab plus b squared. So 1 square, I get 1. This is the extra 1. I don't want this one. So what should I do with this one? Naturally, I have to put a minus 1 here. That's the extra term, which I don't want. Okay, so to tidy this up, this is what I eventually get in my left hand side from this to this. Now let's solve it. This minus 1, I can move it to the right hand side. Okay, this is slightly different from the factorization method. You don't have to ensure that one side is equals to 0. That's not what you want. Up until this step, we will be able to see that if this square is 16, so x plus 1 is equals to 4, people will see that. Most students can see this, but they'll forget the other part. Or x plus 1 can be equals to negative 4. Don't forget, when you square this, there's a plus, minus. Okay, so x is equals to minus 1, x equals to 3, or x equals to negative 5. A general guideline is whenever you solve a quadratic equation, most likely you will get two answers. So don't forget, there should always be an or, okay, if done correctly. One last question before I end this video. So what is the variation here? What is different? The difference is initially, before that we're handling plus. Now we try one question with minus. Okay, that's how your text would like to vary out and make sure you understand. So I want to solve this. Again, the standard one, I move this constant term to the other side. So plus 5 on both sides, that's how I get 5 here. This, okay, my x squared, that's how I get my x squared, minus 3x. So before that, I have to halve this. Okay, because if I expand, I double it, right? 2ax. So now I halve this. So minus 3 over 2 equals to 5. Wait, but this is not the end, okay? Check. You expand this. I get x squared minus 2ab, which is 3x. See, I get x squared minus 3x. 3 over 2 square. A squared minus 2ab plus b squared. So this plus b squared, this term is the extra term. Okay, from here to here, I have this extra term now. How come I have this? So I don't want it. I have to minus it away to ensure that they are still the same. I'm just changing the way it looks. So let's tidy this up. minus 3 over 2 square equals to 5. Okay, if you don't believe me, you can just expand this whole thing. You expand this whole expression, you are going to get back x squared minus 3x. They are the same. They just look different. So I keep my bracket on the left hand side. I move this constant term to the right hand side. So this 5 plus 3 over 2 square, which is actually 9 over 4, is 29 over 4. So I know that x minus 3 over 2 is equals to positive square root 29 over 4, or don't forget the negative value. There are always two, there are not always, but most likely two solutions. Very likely, like 99% of the time, you should get two solutions for your completed square. So I have x equals to square root 29 over 4 plus 3 over 2, or x equals to negative root 29 over 4 plus 3 over 2. So you can use your calculator to simplify. 29 over 4 plus 3 over 2 equals to 4.19258, which is equals to 4.193SF, or negative 1.19258, which is equals to negative 1.193SF. So for completing the square, there's really no shortcut. Practice makes perfect. After you practice a few more times, you will naturally get a feel of it.